Hey everyone, welcome back to another episode with 3D CAD Masters. So today what I'm going to show you is I'm going to show you how to incorporate the concepts from our last video into this video by drafting this prototype, including a triangular prism, a rectangular prism, some holes, kind of extruding another triangular prism at the top of the triangle. Lots of concepts that are going on in here that bring those 3D shapes, drafting those, modeling those into the program. And then I'm also going to do a quick tutorial on how to use this tool called a caliper, which is what you use to measure 3D tangible objects so that you can go ahead and put them into the electronic virtual version. So first off, we're going to start with something pretty simple. This wacky looking shape, which is really just a cube. So what you're going to do to start off, you want to make sure to zero it out. Always zero out the caliper at the tightest point. So squeeze and zero. Then what you're going to do is you're going to spread it out, clamp down the edges that you'd like to measure, and because this one, whenever you clamp it down, it measures a lot, you're going to want to make sure to hold your object still and kind of hold it against one edge like I am with my finger, like that, and push it in slightly. And then there are two ways to go about getting your exact measurement. You can pick it up like so and write down this measurement here. Or what I like to do is I will tighten this knob right here and I will pick it up, and now the caliper can't move, or it can move obviously, but the tighter you tie it, the harder it is to move, so that you can play around with it a little bit, play around with the object, such. So that's the second way to do it. The third way to do it, this is how I like to do it. What I do is once I get this measurement, I zero it out. So now that this is zero, if you go forward, it's gonna be positive, right? If you go backwards, it's going to keep that same number as this measurement that we took here with a negative sign, but it's the exact same measurement. I like to do it like that because there's a lot less room for error, and you just make sure you get it at zero every time, just like that. So then the second thing I would like to talk about with these measurements is how to measure, how to measure something that is much longer than the actual caliper. So let's get that to be still for a second. So we can see if we spread this object out, it's much longer than about 6 inches, right? Because this one rolls a lot, we're going to get a different one. This one has been 3D printed to like stand still, with the tube at the bottom. So what you would do is you start at your base here, and see how I pinpoint this point right here at the end. I'm just going to pinpoint exactly where it is. I'm going to write down 6 on another sheet of paper, and I'm going to close the caliper. It works a lot better if it's on a flat surface, but we don't want to be too choosy, and try and get it to not move as much as I'm moving it now. Normally you're not going to have to design something too gruesome like this. And then we're just going to, because it's zeroed out down there, write down that number, and then pull it out and add that number to your original measurement, and that's the length of your full object, right? And then the last and final thing I'd like to go over is how to measure a hole. So this is a functioning 3D printed whistle. So what we're going to do is we're going to measure the long side of this hole, like this. You can't use this because it's not accurate enough, because you're taking some of those dimensions off. You could measure each edge and then measure the whole thing completely. That just is very time consuming. So what they have on this end here is a side for measuring inside from the inside of something. So you're going to do the exact same thing. You're going to pull and see how it comes apart and it meets each edge. So now I'm going to zero it out. It was 0.5 inches, and then there you go, you've measured the inside of a hole. So that is a tutorial on this caliper here. And then one thing to be very careful about whenever you're using a caliper, these points right here are very sharp, so be careful not to play with it too much, because you could poke yourself and hurt yourself. And then another thing, these are also very sharp, but they're also really flimsy, especially if you have a plastic caliper. If you have a plastic one, they're very easy to break, and you would be able to see the break on the end of here. So make sure that whenever you're using these calipers, you use them with sensitivity, caution, etc. Right? So let's go ahead and jump into drafting this prototype. I'm going to go ahead and shut off the camera because there's nothing else to demonstrate, but hang tight with me while I get us situated. So let's go ahead and start off with the top view. The connection point between the rectangle and the triangle, which are the two lines that I'm drawing right here, we are going to leave those off for right now because this special object has an immeasurable measurement, which is that line. We will find out how to draw that after we've drawn the front view. So now let's go ahead and move down to the front view. And then once we get done with the front view, I'll show you why we can't yet complete this part of it. The top and front view are very similar, except the front view simply doesn't show the protruding triangle, which has a height of 7, which means you will need to use the ruler for this. And then you can just erase the marks at the top while you're erasing the dashes for your hidden lines. Okay, so now, as you can see, this point here where the rectangle meets the triangle, it's not all the way to this grid point, so we can't measure it exactly. It's not an exact measurement. What we can do is we can use reference lines, and you just kind of eye it. From this point you can go up. So you can see it's basically in the very middle of the grid lines, and then we can go in with our black and we can create our endpoints, is what I call them, our endpoints. So now we will draw the reference lines for the right side view. And for the right side view, we don't really need to see the actual model, so we're just going to go ahead and zoom in here because you already have an idea of what the object looks like. And we can draw those hidden lines from the hole. And we know that their diameter is 2, so then their units are 2 as well. And then there we have it. We've got our model drafted and everything like that. If you guys have any questions to ask about the caliper, about including the concepts from the shapes into our prototypes, feel free to comment down below. Also comment down below anything you guys would like to see from us, and we'll be sure to get on that. Go ahead and follow us on Instagram. Our username is in the description. We want to hear your questions you have for us. DM us any questions, comment any questions in our comment sections, reach out to us. We are happy to help. And I assure you that whenever you are commenting and DMing us, it is us that is replying to you and not a automated message, right? And then go to our website, which is right here. And you can sign up for classes. You can email us. You can call us. Anyways, thank you guys for coming in, watching. I hope you guys enjoyed, and I hope you guys go out and get a caliper, get familiar with it so that it'll be common sense by the time you get to our class, because you are signing up for a class. Okay, thanks guys. Have a great day. Bye. See y'all next time.